In this homework video, we're going to have a look at interpreting tables and charts, and specifically Carroll diagrams and Venn diagrams. This video is for all of Year 6. To be an effective mathematician, it's important to be able to look at a table of information and figure out what it actually means, what it's actually telling us. Have a look at the table here and see if you can answer the 3 questions relating to it. So for the first question, it's important to recognise that we're looking for the 5th journey, and how many passengers are sharing the cost? Well, there's 4 of them, and that's £12. So of course it must be £12 divided by those 4 passengers, making a total of £3 that they have to pay each. For the second question, what fraction of the journeys had 1 passenger? Well, of course we'll be saying, well, what are the total number of journeys? There are 5. And how many involved 1 passenger? Well, there were just 2 involving 1 passenger. And then the last question, I think, is the most difficult one. The key here is noticing that this journey here is 7 kilometres, and it actually costs more than £7, whereas all of the other journeys, the cost in pounds is less than the distance in kilometres. And so, as you can tell there, so this journey must have been the slowest. Covered the smallest distance for the greatest amount of money. Now, Carroll diagrams are used to sort information. Here, they could be used to sort information about the staff at Bradshaw Hall Primary School. See if you can fill in this Carroll diagram. Here's how I've done it. You can see I just need to make sure that the teachers in this column are male, and this column are female, and then of course I've sorted them this way by teaching and non-teaching staff. Now, I wonder if you can use the same principle, but just using a numbered example. Have a go at filling in this Carroll diagram, and work out which box can only be filled with 1 number. So, of course, I'd check the numbers in this box by trying to work out, are they both odd and primes, like 3 and 59? Of course, there are many others. Square numbers that are also odd, so for example, 5 squared is 25, 7 squared is 49. Similarly, even square numbers, I've got 2 squared and 10 squared there. Now, of course, even prime numbers, there's only 1. Every other even number has 2 as one of its factors. Now to Venn diagrams. So Venn diagrams are used to sort information as well. Except unlike with Carroll diagrams, there can be an overlap of the information. So, for example, if we have a look at the top one, you might like tea and like coffee, so you could be in both categories. The top example, which we'll come to later, shows of a survey how many people like tea and like coffee, and you can see there's 4 different spaces in this traditional Venn diagram. Those that like tea, those that like coffee, those that like tea and coffee, and those that like neither tea nor coffee. Now, have a look at the 2 Venn diagrams below and see if you can figure out why the circles have been laid out in a different way. Pause the video and have a think. So, if we have a look at the example on the left, you can't have a number that's a 2-digit number and a 3-digit number. Those 2 can't overlap. Your number would either have to be in this one, or it would have to be in this one, or it would have to be on the outside. But what it couldn't be is in both of them. And if we have a look at the example on the right, multiples of 4, well, why isn't that box kind of overlapping here, if you like? Well, if you think about it, all multiples of 4 will also be multiples of 2. So there couldn't be anything in like this bit, because if it's a multiple of 4, it must also be a multiple of 2. Now, on the bottom 2 Venn diagrams, see if you can get the numbers above them and put them in the appropriate place in the Venn diagrams. So, if we look at the first one, 2 is not a 2-digit number, a multiple of 5, or a 3-digit number, so it has to be on the outside. 20 is a 2-digit number and a multiple of 5, so it has to be in both of these circles here. 201 is a 3-digit number, not a multiple of 5, so it only belongs in this circle here. And 2000 is a multiple of 5, but it's a 4-digit number, so it's got to be outside of this circle and outside of this circle. Now, if we have a look at the one on the right, well, I'm going to look first for multiples of 4. There's only one there, and that's 12. And I can also, I'm just going to cross that off. Now, I also know that 11 isn't a multiple of 2, and neither is 13. So they can both go on the outside. Whereas 10 is a multiple of 2, but it's not a multiple of 4. So it's got to be in the outside oval, but not in the inside one. Now, notice that the 12 is actually in both circles. It is in the multiples of 2 circle, and it's also in the multiples of 4 circle. So we're going to try and combine some of these areas of learning that we've had a look at on this video. I want you to see if you can get the names of the children from the table above and put them in the correct spaces in the Venn diagram below. So for each person, it's like you're asking yourself 2 questions. For Alfie, has he got more wins than losses? No. Has he got more draws than losses? Yes. So he must just be in this circle here. Megan has got 2 wins, 2 draws and 2 losses, so she just must be on the outside. Neither more wins than losses nor more draws than losses. Chen has got 3 wins and no losses, so he's got to be in one circle, and he's also got more draws than losses, so he's also in the other circle. Donna has got more wins than losses, but she didn't have any draws, and she did have 2 losses, so she just must be in more wins than losses. And finally, Tom has got more losses than wins, so he's not in the left-hand circle, but he's got more draws than losses, so he is in the right-hand circle. So here, we're coming back to the Venn diagram that we saw before. A survey of people asked if they like tea or coffee with the numbers in the appropriate spaces. So have a go at answering the 2 questions based on this. Pause the video. Okay, so firstly, I need to figure out that there are 18 people who like tea and coffee, 18 where we're in both of the circles, and that's 18 out of a total of 50. Now, of course, to work that out as a percentage, I need to know what it would be out of 100, which, of course, would be 36 out of 100, or 36%. And for the second question, to work out how many people don't like coffee, I have to work out which ones are outside of this circle, which are, of course, the 3 that just like tea, and the 20 that don't like tea or coffee. So I'm looking at 23 out of a total of 50, which is, of course, 46%. And finally, straight from first class maths, I want you to have a look at these 2 Venn diagrams and see if you can figure out which famous saying each graph represents. If you manage to do that, see if you can think, why is the information laid out in the manner in which it has been here? The one on the right, you can't teach an old dog new tricks. If you have a look, trainable animals include dogs in the middle here. You can teach a young dog tricks, but old dogs, well, they're a domestic animal, but they're not trainable. So you can't teach an old dog new tricks. The second one, things with silver linings, will notice that all clouds have silver linings. The cloud circle is on the inside there, so there can't be a cloud that doesn't have a silver lining. So therefore, every cloud has a silver lining. Great stuff. We'll see you in class next week.